Good afternoon, sir.
Good afternoon. So, Dr. Devanshi, can I share my slides?
Sir, I'll give a short introduction about you, then you please share your screen.
Sure, please.
Shall we start, sir?
Yeah, I'm ready.
Okay, sir. I welcome you back to the third session of day 2 of this short-term training program sponsored by AICTE on water quality complication, restoration, and environmental conservation of existing water bodies, Module 1. We have with us Dr. Arvind K. Nema, sir, who is a professor at the Department of Civil Engineering, Institute of Technology, Delhi. He is a PhD from IIT Bombay. His areas of interest are environmental engineering, modeling, simulation, optimization of environmental systems, integrated waste management, and environmental impact assessment. We are honored to have you with us today, sir. Thank you for taking time out of your busy schedule and enlightening us with your experience and knowledge. I request you, sir, to please share your screen and proceed with the session.
Thank you so much. I'm really thankful to IPS for giving me this opportunity. I hope I am audible.
Yes, sir. You're clear, sir.
Okay, thank you. Thank you. So today I'll spend some time with you and try to share some of my experience in the field of environmental engineering. To be precise, we would like to discuss a few things from my side, and I'll request you to keep giving me feedback so I also learn. So may I share the slide, please?
Yes, sir.
Yeah, give me a minute, please. Right, so my slides can be seen.
Yes, sir.
Okay, thank you. So we will talk about something slightly different than the conventional topics. We'll talk about, I'm sure all of you must have heard about contaminated sites. When I am talking about contaminated sites, I am talking about legacy waste, meaning the waste which has been dumped somewhere either in low-lying area, legally or illegally, or even if somebody has dumped or disposed of the waste taking proper engineering care. However, due to several environmental factors, the waste is now leaking into the environment. So what are the remedial measures we need to take? That is one of the major questions in front of everybody, including the regulators, the industry, or should I say the polluter, not necessarily industry, because sometimes even the municipal corporations are the polluters. And before answering that big question, how should we remediate? We need something very quantifiable in terms of up to what extent should we remediate. For example, I'll take you to two different examples where there is a significant amount of pollution. If you compare the pollutant levels with the background level of pollution. However, once regulatory agencies decide we need to decontaminate, the cost of decontamination exponentially increases with the quantity of pollutants you would like to remove. If you would like to bring back the virgin conditions, the cost is exponentially high, and most of the time it is unaffordable by any industries. So what should be the polluter pays principle says that we have to bring back to the virgin conditions. However, many a times the cost becomes such a prohibitive factor that it is very difficult for us to achieve. So the question is, what regulatory agencies say in terms of the standards related to site cleanup? So we will discuss something on that. This topic will relate to water pollution in terms of saying surface water contamination and also groundwater contamination and remediation of the soil which has become contaminated, and until unless you clean up this soil, source of pollution is not going to go away. So we have to identify the site which is now source of the pollution. Remember, it is not continuous source of pollution. Somebody has contaminated the place and gone. So some industries which are responsible for this are no longer maybe existing there now. They have closed down and gone somewhere else, or some situation of this kind where it is even difficult for you to pinpoint who the polluter is and how to make the polluter responsible. That is a case A. Case B is case A when I am saying there could be multiple polluters and even there is a cocktail of pollutants, meaning there is a mix of several type of pollutants which are present in the system. So your decontamination strategy is going to be very different. There could be another case where there is a known industry which was responsible for this particular pollution. However, in the absence of site-specific cleanup standards, they do not know up to what extent they should decontaminate or remediate the site. So this lecture will revolve around these as thoughts. Interestingly, I'm sure all of you present here are mostly concerned about air pollution, water pollution, noise pollution, and so on and so forth. Various environmental rules, regulations, laws are there in front of us, which can be selectively applicable depending upon the situation. However, in case of soil contamination, it is very difficult for us to find out what the regulations say. Very difficult, because if you apply the same rules and regulations onto a agriculture area, it is going to be different as compared to an area which was earlier a mine. So abandoned mine area, if you apply the same standards, you will not be able to work upon what should be the situation. So I did two various different cases. One was related to a detailed case study for the industrial area of Ghaziabad in Uttar Pradesh. So you will find some notes during my lecture related to that. Second case will relate to mercury contamination in the area of Kodaikanal. This is a famous hill station where there was mercury contamination because of the thermometer manufacturing company. So we'll discuss these two cases. We will also discuss what is the methodology. Interestingly, there was no approved standard methodology for finding out site-specific cleanup standards for the contaminated soils when we did the project. And our methodology was accepted by Central Pollution Control Board, Tamil Nadu Pollution Control Board, Uttar Pradesh Pollution Control Board, and endorsed by Ministry of Environment and Forest for various other contaminated sites. So I hope you will find it interesting in terms of its application over various other sites. Just to give you a overview of the whole situation, we have various sites which are contaminated, as you all may be knowing, but the extent of contamination is very different in all these sites. When I say extent of contamination, I am talking about two things. Number one is how much is the contaminated area. If it is just 10 meter by 10 meter area, which is a very small area, I would say, versus the area of, let us say, 10 to 20 hectares, which is a very big area. But at the same time, it's not only the size of the area which matters, but what kind of contamination it is. Is it chromium related contamination? Is it mercury related contamination? Is it general municipal solid waste, which is just because of that there is high BOD and high COD wastewater coming in? So the problems are very different in each of these cases. So we will discuss these two cases. Ghaziabad case is where we have multiple industries, we have multiple pollutants, and even source of this pollution is many times dispersed. Groundwater is polluted, soil is polluted, also surface water is polluted. Second case, there is a single pollutant which is mercury coming out into the soil and the surface water due to the fact that the mercury related contaminated waste was mishandled. It was not handled properly following the rules and regulations. So these two cases we'll see. Right, I'll move to the second slide. Right, this is the title slide which says that we will talk about primarily case studies. I'll move on quickly here. So what is the objective of doing this is here. We would like to first of all try to understand what is site specific cleanup standards. So for example, the I'm talking about, let us say, one case which is Kodaikanal, and the mercury has contaminated the soil and the surface water. Uh, so we should know that if you are asking the industry to decontaminate and the mercury levels are, let us say, 1000 ppm to begin with, it won't be 1000 ppm in each of the grid point of the site which you have surveyed. Let us say it goes maximum to 1000 ppm and the lowest point which is contaminated is, let us say, 50 ppm. So you have to figure out a way of doing averaging and say this site is contaminated with mercury and the contamination level is, let us say, 250 or 300 ppm, which is actually too high. And so you should decontaminate. But up to what level should you go for 0 ppm of mercury in the soil, or should you say that it should be 20 ppm, should you say it should be 50 ppm, should you say it should be 100 ppm? We have very difficult thing to answer now. The reason is site specific cleanup standard means what? We need to carry out a detailed environmental risk assessment for the purpose. And depending upon the uses, is this site used for recreational purposes? Is this site used for agricultural purposes? Or whatever is the intended purpose of this site, we will have to calculate what is the risk which any receptor will be subjected to if you later on decide to use the site. So depending upon that, the decontamination levels are different, because we are interestingly targeting that this site should be safe for humans as well as other ecological factors which may be responsible for using this site later on. So not only human being, but even ecological factors are directly linked when we discuss this as an issue. So site specific standards will talk about three things. Number one, technically it should be feasible to decontaminate up to that level. Number two, economically it should be feasible to achieve the decontamination level. Otherwise, what happens? Most of the companies will otherwise declare themselves bankrupt and go. That is a stalemate situation. In case that happens, then you still will have the problem in your hand, and although you may penalize the company, but it won't help really. So we have to go for staggered way of defining that, okay, phase 1 you decontaminate up to this level, phase 2 you decontaminate up to this level, and so on and so forth. So we try to work it out. Third thing is how much is the safe level of pollutant contamination in the site. So these three things we try to work out. So how do we work out is interesting, and we will see it subsequently. Okay, so first thing is you carry out environmental monitoring of all the abiotic and biotic components which are either on site or closely connected to the site. These will typically include plants which are prevalent there. These will include the soil, surface water, subsurface water, and the living organisms in this system. And the important thing is, once I said this, you have to collect samples. So for soil, it is easy. You can divide the site and the associated area into a grid of, let us say, 500 meter by 500 or 5 meter by 5 meter, depending upon the size of the site. You collect enough number of soil samples, bring them in the lab, and analyze it for the pollutants you suspect that that particular industrial operation or the use or misuse of the site must have created. So Kodaikanal site was very easy for us because we knew for sure that there is going to be mercury in the samples. The story of Kodaikanal is also very interesting. So we had Ponds India Limited earlier in somewhere in 90s, 1990s, and that company was making glass-based thermometers. In the site of Kodaikanal, they had 20 acres of site where they had this factory of making glass-based thermometers. They were using mercury that time. Mercury was allowed to be used that time. During manufacturing process, 0.1% of the thermometers will break down due to some issues in the operations and manufacturing process. So, and what will they do is this glass, which is in the form of a scrap, is collected and kept at some place within the industry premises. Every year they will do auction of these broken glasses, and few tons of these broken glasses will be collected by the glass recyclers. That used to be the simplest of the system which was present here. This continued for 5-6 years, and at the end of 6th year there was sudden report of about 8 people who were actually handling this waste. The workers died because of the mercury poisoning in Madras that time. So as soon as this news broke, uh, that was a very interesting situation, that suddenly there is mercury poisoning happening and there are sick people dying in Madras. Madras is far away from the place where they were actually handling the glass. But once in a year they will go handle this waste and come back. They are doing so many other things as well, obviously. So mercury poisoning was very difficult to trace. So it took a year's time to understand really the basic source is Kodaikanal thermometer site, manufacturing site. Once it was done, then there was a team from Central Pollution Control Board and Tamil Nadu Pollution Control Board who did a very thorough survey of the site. They discovered that mercury contaminated broken glasses are normally kept at the site and which is sold to the glass recyclers as a scrap. They will go and recycle without even bothering that there is a trace amount of mercury in it that could be very dangerous for the people who are handling. Interestingly, it was inorganic form of mercury there. So what happens is this industry was closed, sealed, in fact, and then the investigations were on. So within 2 years of time, there was another report coming from the Palmer Solar Reserve, bioreserve, that there is a fish death reported in the water, again due to mercury poisoning. So that means what? The site and the surface water body which I am talking about, which I am referring to, is about 10 kilometers away, 10 to 12 kilometers away. But there is a steep slope. This comes under Nilgiri mountains, and there is a steep slope towards the river, Pambashola river. So this mercury through surface water even reached to that river water body, and it became part of the fish, which some people may consume and then get contaminated with the mercury. So the site is not the only place where we need to do investigations. We need to do investigation across its path where the surface water is flowing and in the surface water body itself. So mercury traces were found in every aspect here, and it was very clear this is the polluter, they need to clean up, how much they need to clean up, everything was very clearly defined. But the question became that up to what level they should decontaminate. This 20 acres of site, if you talk about, and if they have to dig, let us say, up to 2 meters, that is their main site, main industrial site. After that, it has migrated beyond the site. So you have to dig all the soil which goes all along the Palmer Solar Reserve, and you have to decontaminate actually few million tons of soil, which is huge and huge task. And if you ask them to do it up to the level of background mercury uh, found in the neighboring soil, that is actually almost you can't even measure the mercury in the virgin soil. So it was so low. So the cost is going to be exponentially high here. Also, if you are trying to uproot so many trees because you have to dig the soil, so the loss of the ecology is going to be enormous, much more than what mercury must have damaged. More than that, you will damage to the ecosystem if you start digging out the soil, you will uproot the plants, you will decontaminate it, and then you will put it back. So whole Palmer Solar Reserve of about 10 kilometer by 1 kilometer strip will get disturbed if you actually start doing decontamination. So you have to take a call. What is less harmful? And up to, meaning you complete decontamination is actually dangerous and more harmful if you start doing that. So you have to find a middle way in terms of deciding what are the hot spots in terms of mercury contamination, and you have to decontaminate them. Plus, again, how do we define hotspots? What should be the threshold level of mercury pollution above which you will say these are the hotspots and you will try to decontaminate? So a complete mapping was done here, and then we tried to understand we have to actually decontaminate close to 18 acres of land rather than this 10 kilometer by 2 kilometer strip across the Palmer Solar Reserve. Hotspots were identified. Actually, there are some depressions where the soil was settling and mercury was settling. Mercury is very high, very heavy in terms of its migration. If you see, it won't travel uh, and spread in a very thin manner. It will be concentrated at certain pockets. Those pockets were identified, and then the decontamination strategy was worked out. So before that, we have to carry out complete detailed survey of that place. Okay, if you compare the situation in Ghaziabad, it's very different. It's no single pollutant there. We have multiple kind of pollutants present in the groundwater and soil and the nearby river, which is Hindon River in Ghaziabad. So very completely different story there. So I'll focus more on mercury related story rather than Ghaziabad story. Ghaziabad story is going to be much more complicated because there are multiple pollutants, multiple industries, and multiple medias are also involved. But in terms of methodology, I'll discuss first the single pollutant, and later on I'll try to use the approach for multiple pollutants. So in terms of doing sampling, various things. Okay. One thing which is not seen in the sampling protocol is who is really affected because of the mercury pollutant. If we again, let us say, start focusing back into the mercury, is it the fish? Is it the soil microorganisms? Is it the avian fauna, or is it only the flora? So several questions came to us actually, and you will be surprised to note that the most critical species is the one which is not directly in contact with mercury. In fact, if you are familiar with the ecology, you will realize that primary consumers, secondary consumers, etc., and predator-prey relationships, if you have to work upon the food web and the food pyramid, energy pyramid, if you look at, we had to do several studies before we could arrive at a very simple fact, which you may find that should it take 3 to 4 months of study to just say that the sparrows present there are going to be the most critical in terms of getting affected due to the mercury. Sparrows and quails. These two were actually, they are avian in nature, but since their foraging area is such that they will get maximum kind of exposure when such a kind of pollution happening. So our focus got diverted from soil to plants to surface water to fish and ultimately to sparrow and quail. So that was one very interesting learning for us. Second thing is mercury is dangerous for human health. So should we worry about human health as well? Yes, we should. And we should also think that what will happen to this site later. Industry is closed, but this 20 acres of land, if let us say tourists visit this site by mistake, or if there are monkeys who may visit this place by mistake, or there is any other animal or any other birds who visit this uh, area by mistake, even if you do decontamination and fence it and leave the site, still there will be something which will keep visiting the place, and they should not be harmed because of the mercury contamination. So that was the idea. Apart from this, there is rain which will keep coming, and then there will be some soil erosion which will keep happening, and due to that there is going to be migration of mercury, and it will keep reaching into the nearby surface water body. So we should keep the mercury levels low at these hot spots. How much was the question? And concentration of mercury reported were in the range of 50 to 100 ppm. That was very high concentration of mercury reported. So with this, we started thinking about our strategy in terms of developing what should we do about the contamination. So you will find this flow chart in terms of our analytical procedures which we followed with regard to analysis and so on and so forth. I'm not going much into the depth of this, but I just wanted to show you this slide that complicated strategy was followed. Also at the same time we started looking at what is the possible technologies which can be applied to decontaminate the mercury. Some experience which we got from the Ghaziabad case helped us in finding out the strategy here. So there are some data which I am going to show you which is related to Ghaziabad, some data which I'll show you which is related to the mercury contaminated site in Kodaikanal. So you will find now some data which is related to Ghaziabad. And in this, one point which I thought you should note is we tried to not only see the metal concentrations in the soil, surface water, sediments, but at the bottom of this river, Hinden, or other things, but we have to also see the metal fracturization, meaning actually if let us say chromium present, then how much is chromium 3 and how much is chromium 5, or similarly if there is arsenic present, then in different forms arsenic can be found. So how much of fraction of what form is present, that also is very, very important. So this lesson helped us in relating our learning for the mercury contaminated site. I'll just please allow me to correlate these two things, because many lessons we draw from the Ghaziabad side and we try to apply onto the mercury contaminated site. See, one important lesson was then what form of mercury should we be measuring in Kodaikanal site. Initially, since it was a thermometer manufacturing company, you will realize that we should be measuring the inorganic mercury typically. But since it was for few years there, and there is so much of microbiology happening in the soil, and every year the rain comes, there is soil erosion happening and so on and so forth, we should also check whether this mercury has started getting converted into organic mercury, methyl mercury. That is very, very important lesson which we draw from the Ghaziabad side. Unless until you do that, you will miss something very important, because inorganic mercury is bad for human health, very bad for human health in fact. However, methyl mercury is further bad for the ecology, very, very bad. Some people say it is 20 to 200 times more dangerous. So please check the literature depending upon where it is and how it is affecting, etc., etc. So we realize that various forms of the pollutant is also important, because we are not in the laboratory, we are not maintaining the virgin conditions which were there at the time of pollution happened. But since the time has changed, there is so much of rain which has come over the years, there is sun, there is the soil microbes, and so there are so many things changing in between, and finally we have to check where are we in terms of the pollution, whether these pollutants have changed the form, and now which form should we be targeting in terms of not only monitoring but even decontamination. So the decontamination strategy for inorganic mercury is very different as compared to methyl mercury. So that was very important for us to understand. So that's why I am showing this slide, because it helped us in understanding uh, the second case. So we tried to relate the lessons from the first case to the second case. Similarly, if you are interested in finding out various factors, so for example, we tried to see how much is geoaccumulation happening. So it was very important for us to understand how much is geoaccumulation happening. And one more thing was which was very, very important for us was to understand that how much is enrichment factor. So enrichment factor, for that we have to find out there should be one similar pollutant, not same pollutant but similar pollutant, which can give us good information about its background. So see, for example, in case of Ghaziabad, we found that aluminium could be used as a background metal, because there was no aluminium related contamination happening in the region as such. We had contamination due to zinc, chromium, arsenic, and so on and so forth, but aluminium was not really found there actually. In case of Kodaikanal site, it was not aluminium. We had to zero upon uh, iron there. So the background thing which became important for us was iron. So we then picked up for finding out geoaccumulation factor and enrichment factor, iron as the base thing for here. So there are a lot of research goes in that when we try to establish this issue. This depends upon the soil type. This also depends upon the basic geography of that area, and the prevalent sources of contamination. So this was also very important exercise for us. We realized that before we talk about safe limit assessment, we should we cannot go by binary logic. Meaning, if we say that 30 milligrams per kg is the safe limit, it is going to be very difficult for us to say that for all types of species which are found in the area or the nearby area, should I say. So we decided to apply fuzzy logic approach. So we said that we decided certain cutoffs using EPA's toxicity handbook, that how much is the tolerance level of various metals and various pollutants in various different species. Okay, for example, if I am talking about sparrow, so I'll say that what is the tolerance level of mercury in case of a sparrow. If I am talking about human health risk assessment, I'll say how much is the tolerance level of mercury in human body, how many ppb or ppm, and so on and so forth. Second thing is, when we talk about understanding the uh, concentration of the pollutant inside the any ecological entity, we have to be very careful in terms of correlating international information in our context. So for example, if you are trying to say sparrow in India and sparrow or quail in US, because the data is available for US, we have to correlate. But then the size of the bird, body weight, the foraging area which these birds will cover, and everything is very different. We cannot directly compare their data to our data. So we have to work upon per unit of body weight and per unit of foraging area kind of parameters we have to work upon. And we try to be safe in terms of our assessments when we applied this fuzzy logic approach, which helped us in taking safer decisions, I would say. So we have to not only worry about human health, but also various ecological aspects. So I'll move on. So we did lots and lots of probability based analysis here to understand that what is happening as the concentration of the particular contaminant we are talking about. This is applicable for both Ghaziabad as well as Kodaikanal site. One thing which is very important for us is, since now we are not only comparing the numbers, meaning if the concentration level is so much, is it good or bad, if the concentration is so much, is it safe or unsafe, rather than we are going for risk assessment. So we have to establish a relationship between source and the receptor through the pathway. So we have to identify which pathway are we talking about. Is it soil? Is it groundwater? Is it surface water? Or is it due to inhalation? So sometimes what happens is soil becomes airborne and it becomes even inhalation as a route, which is important for us to consider. So pathways are very important. Second thing is, when you choose the receptor, you have to be careful in terms of choosing the receptor which is most critical in terms of its susceptibility to the particular environmental condition we are studying. So one possible receptor is obviously human beings. And but remember, when we talk about even human beings, we have to divide human beings into various groups, because the body weight, the reactions due to that particular pollutants, and the diseases or any damage which will be caused due to that particular pollutant is going to be different in case of male population versus female population versus child population. So because the metabolism is very different, body weights are very different, even the exposure and frequencies are very different. So we have to consider all these with regard to all the possible routes. We tried to consider three primary routes. One was the inhalation route. Second was the oral route. That means if something is in the surface water and due to which you consume something, let us say fish, or drink that water. Third thing was dermal route. If somebody comes in contact with the contaminated soil, then through dermal route also there is a possibility of getting affected. So for human beings, we finalized that there should be three categories of population group: male, female, and children. After calculations, we realized that children are most susceptible group with regard to these contaminations. And in the ecological components, that was most difficult part. And see, we explored various things actually. We explored several types of species which covering flora and fauna, and finally we zeroed in on, as I have already told, sparrows and quail. So different routes, three different groups in human beings, and various ecological factors. All those things was this thing was done. One more thing is, when we talk about human health risk assessment, we have to talk about at least two categories of diseases. One is cancer related diseases. Second thing is non-cancerous diseases, or the risk due to non-cancerous diseases. So these two things we covered in terms of diseases. So if you subdivide everything, there are so many study groups we are talking about. With regard to humans, three groups. With regard to ecological entities, there are several groups. With regard to diseases, there are very two clear groups: cancer and non-cancer related risk. And again, pathways. There are three clear pathways which we tried to cover. When we come to the ecological risk assessment, then another complication happens is we have to cover even the food web and food chain, because sparrows are not directly in contact with the mercury contaminated soil, but they come for foraging and eat some insects which are contaminated with mercury. So their food chain we have to study that way. So it became very involved study. And finally, I would like to show you a few things which which you will probably appreciate in terms of calculations. So there are two things: human health risk assessment and ecological risk assessment. Human risk assessment is more common, and you will find the literature much more easily. It is a standard. And ecological risk assessment was more complicated for us. So we had to figure out what is the right species to be picked up. So there are two things. One is that species particularly should be prevalent in that region. One. Second thing is, with regard to the particular pollutant we are talking about, they should be most susceptible. So when I say most susceptible, it is not only in terms of concentration, in terms of its body weight, in terms of its foraging area, in terms of its eating habits, everything we have to cover, and then finally figure out what makes that particular ecological entity most susceptible with regard to the particular pollutant we are talking about. So these are set of, some of them are assumptions, some of them are assumptions translated into Indian situation, and so on and so forth. So these became the basis for our much more detailed calculation with regard to safe. Our idea was to calculate the safe level of mercury level, up to which if you decontaminate to the at the hot spots, the whole situation is going to be safe. So once we did this, we had detailed set of calculations, and we found that 22.42 milligram per kg was the safe level of mercury in the soil. This is interesting finding, because largely the NGOs working there and even the local public, they were very unhappy with this finding. They wanted to say that it should be matching with the virgin soil level. Virgin soil level was below detectable limit of the mercury, and we found that if you decontaminate up to this level, you are going to be safe with regard to human health risk assessment, and also with regard to risk to any ecological entity which is either using this particular site directly or indirectly. So interestingly, this whole thing went on for a huge debate at first Tamil Nadu level, because the Tamil Nadu Pollution Control Board organized several meetings of NGOs, the industry which was responsible for the contamination, and Central Pollution Control Board, and various subject area experts. So it was discussed, debated, and everything, including NIRI, because NIRI was responsible for providing the technology which should be used to bring down the mercury level to the required level. So should it be 0? Should it be 22.42? Should it be 44.36? That mattered a lot for the stakeholder which was responsible for providing the technology for remediation and decontamination. So this is what was finally recommended and actually accepted by finally all the stakeholders. Even interestingly, NGOs agreed upon these numbers after initial resistance, debate, and providing them with sufficient literature and everything. Finally, this is what was agreed upon, that if they decontaminate up to this level, this is going to be fine. And the work started towards the decontamination of this site from the mercury to achieve these levels. ERM and NIRI are working towards making this site cleaner or safer with regard to ecological habitats. So that is one thing which I thought I should discuss with you. About the Ghaziabad, we found that the contamination levels are high, but there is as such no big risk to ecological entities. We don't have any sensitive species in that area. Major risk is to the human population, because the Hindon river water is ultimately joining in Yamuna river water, and Yamuna river is actually part of the drinking water source for many big cities in North India. So human population is affected badly. Rather than ecological species, human population is affected badly. Second thing which was very important for us to note with regard to this Ghaziabad case is there were several pollutants which are there present in the soil as well as surface water. It was not only single pollutant like mercury in the case of Kodaikanal. Here we have several pollutants which are present there. The bigger problem was actually not the direct use of the surface water. The problem was the surface water is being used by the farmers in growing their crops. So many a times this is becoming part of the food chain indirectly. They are growing vegetables, they are growing several things using this water from the Hindon River. So that is the major concern. If somebody is buying those vegetables unknowingly, they are getting exposed to these pollutants. So Ghaziabad site was declared as a critically polluted site. So the agriculture related activities were given warning, and alternate source of groundwater was supplied to them for the purpose. So they don't use the Hindon River water for the agriculture purpose. So Hindon River water was not allowed for them to be used as the source of water for irrigation. That was one, because there were several problems with the Hindon River water. Second thing is, we struggled a lot in terms of finding out what should we do with regard to decontamination of the soil which is present on the bank of the river Hindon to decontaminate it. It was very complex task, and we even checked what happens at the time of floods. Then there is a reverse thing happening now. Soil sediments, the bottom sediments will come on the shore, and the shore sediment will get washed away and become part of the river. So there is a very detailed kind of flood routing, then mathematical modeling happened there, and a lot of land use practices were accordingly monitored and regulated in the Ghaziabad area. So what I'm trying to say is these two problems also helped us in understanding the solution for the other side, but the solutions are very different, problems are completely different, strategies are completely very different with regard to Ghaziabad and with regard to Kodaikanal. But the lessons learned from one side help for the other side help for the one. And one very different outcome which came out of the Ghaziabad study was we tried to find out there should be an index which talks about in general environmental health of the area. And when I say environmental health of the area, we should be talking about air quality, surface water quality, as well as soil and groundwater quality. So you should be able to calculate that index, which is a surrogate number indicating the pollution level, and if that number is beyond a threshold number, then you should be setting the alarm that this site needs attention of the regulatory authorities and we need to do something. Also, we need to set an alarm that environmental resources present in that particular area, which is beyond this threshold number, should not be used for any purpose which may directly affect either human health or any component of the ecology. So that was very interesting lesson. So we calculated and found that there should be a CEPI index, Comprehensive Environmental Pollution Index. That that index came out of the Ghaziabad study and applied across various sites, and we realized that if the threshold number is 70 and above for this CEPI, then the site is seriously contaminated, severely contaminated, and the environmental resources present there should be very carefully used. And preferably they should not be used for anything which can directly affect the human health and ecological health. So that what is some interesting thing I thought I'll share with you. I'll be stopping here for 5-10 minutes and will request that in those 5-10 minutes, if there are some questions, they may be asked. Because in case I'm going fast, if I'm not really explaining something clearly, I'll be happy to answer. I'll hold here and then wait for the questions.
So anybody who is willing to ask any question or doubt or would like to interact with sir, you can type in the chat box or you can come online.
Anything if you find worth discussing, I'll be happy to answer. You may find some new words here. Anything which you feel is not clear, you may ask. Anything which appeals.
So I would like to ask something.
Please.
Sir, actually, usually we perform monitoring and assessment of certain pollutants into air or water sort of things. But if you want to relate what is the contamination degree of that particular component, how do we proceed with that, sir?
Right. So if you know the uses of that particular area, is it residential, is it industrial, or like that, so you can carry out risk assessment. So this is the approach which I'm presenting here, and most of the countries are now going for this approach rather than just saying that sulfur dioxide levels are beyond the regulatory limits. They actually do risk assessment, which is not difficult thing to do, and they actually say that so much percentage of your susceptible population is at risk. For example, Delhi, you may find in the winters they suddenly start saying that odd and even rule is coming, half of the vehicles are not allowed, and so on and so forth. So far the decision is only based on the pollutant concentration. So far, it is only based on the pollutant concentration. If the air quality index, which is actually based on the calculation of pollutant levels, is more than so much value, then we trigger the red alert, and then we say that so such and such and such and such activity should be banned for this particular period of time, rather than doing risk assessment. And in fact, if you do risk assessment, you so what is the difference actually? Risk assessment also is based on the concentration numbers of these pollutants, yes. However, it also depends upon the population distribution and the susceptibility of the population. So if you know, for example, pollutant levels are high close to a children's school or an old age home or a hospital, then the same numbers mean different with regard to pollutant concentration level. So, or similarly, not just the pollutant concentration number, if you look at the meteorology, which is very bad in case of winter season in Delhi, so the same numbers, let us say if I talk about particulate matter 2.5, so a concentration of X microgram per meter cube means different in summer, it means different in winter, because our whole metabolism, our respiration, the meteorology of the atmosphere changes. So what I'm trying to say is risk assessment will account for all these fine things, and actually it will give you much clearer, much better picture with regard to safety in terms of human health as well as other ecological component. So we are going one step ahead, and we are going finer in terms of our health components, ecological as well as human health. Depending upon the weather condition, depending upon the uses, we are refining our numbers by saying we are not sacrosanct about this 80 microgram per meter cube, but in certain weather conditions it could be even 60 could be more dangerous than 80. So like that, and sometimes even 120 can be tolerated depending upon the weather, depending upon the uses and so on and so forth. So this is becoming more dynamic in nature, more realistic in terms of carrying capacity of the region or the atmosphere or the system, whatever you want to say. So we are moving towards that. So what happens? Overall productivity of the region will remain same or maybe enhanced if you regulate it slightly more carefully.
So one more thing,
Yeah, please.
that regarding the contamination indices, what I have studied, sir, that we usually calculate the ratio of certain things into the soil, and then we find it out with that
Correct.
the
Correct.
contamination degree. But sir,
Correct.
if we are studying a particular component in air quality, then how do we proceed with that same calculations?
Correct. So soil related index and air related index are very different. So in case of air quality index, we do not find out the ratios. What we do is, if you have seen the National Air Quality Index, which is being reported in the newspapers also many times, so they report, we have 14 different pollutants for air quality, for example, which we monitor. So they say you must monitor at least three, including PM 2.5, and then that's a must, actually that's a condition for you to apply air quality index. That is one. Second thing is the pollutant which is exceeding the regulatory standards by a maximum factor is your most critical pollutant. So air quality index is going to be based upon that particular pollutant which is exceeding the standards by a maximum factor, and that is converted into a number between 0 to 500, and accordingly air quality index is reported. Soil quality index is very different. We talk about soil quality index is completely different, actually. We talk about the ratios which you have correctly said, that geoaccumulation index, etc. we calculate, and hazard quotient we calculate, and we report that. So soil is more relative, air quality index is more absolute, I would say. So very different approaches are applied for soil and air quality. You are absolutely right in pointing that out. It's a very good question.
Thank you, sir.
Sir, I have one question. Sir,
Please.
my question is how the fuzzy logic approach is held, or sir, other than further fuzzy logic, or any different approach is available?
Okay. So if I say fuzzy logic approach helped us in, see actually what is happening, if I'm talking about 20 acres of area, for example, and I have even divided the area into a grid of let us say 10 meter by 10 meter, which I would consider as a very fine grid. 10 meter by 10 meter is going to be very fine grid. I have to do many numbers of samples, correct? Because it's not just every grid point one sample is not enough. You have to go deeper and then collect the sample, let us say 15 meter, 30 meter, 50 meter deep, and so on and so forth. You have to collect depth wise also. So each grid point is again multiplied by 3 or 4 as a factor, correct? So many samples you will have to collect and analyze. And even if you keep increasing the number of samples, you cannot have infinite number of samples to become 100% representative of the area. That is one. Second thing is, soil is a very heterogeneous system. We cannot say
Yes.
this is a homogeneous system, right? So in order to say your values are representative, right, the
Yes, sir.
simple calculations or simple monitoring values are not correct and true representation. So we said that these numbers which you collect should be subjected to fuzzy logic approach, and then you say that these are hot spots, these are moderate spots, these are low spots, and so on and so forth. So we instead of saying that these 300 or 400 samples which we have taken and this is the maximum, this is the minimum, and this is the average, we try to use our fuzzy logic approach in terms of defining the pollutant levels in the coarser grids of the area which we try to cover. So fuzzy
Yes.
logic approach helped us in making the isoplates or concentration gradients of the mercury in Kodaikanal site,
Yes.
rather than saying these are the unique numbers which we have seen. Another problem is when we went for sampling, we found some numbers. If somebody goes there 2 years later, they will find some another number, right? Or if somebody uses instead of 10 by 10 grid, 5 by 5 grid, they will find another number. So what I am trying to say is nobody can be representative truly. So rather than that, saying that these are the absolutely correct numbers, we went for saying subjectively but qualitatively these
Yes.
are our spots which are in the range of 750 to 1000 ppm. These are the moderate spots which are in the range of 250 to 750 range, and so on and so forth. We divided them into classes and then we represented rather than saying precisely this is the concentration, right?
Thank you so much.
Thank you.
So there is a question in the chat box
Yeah, please.
by Sangeeta Agarwal. That could
Yeah.
you explain IGO factor?
Okay. So I think you refer to that factor. I'll try to go to that slide if possible. This one you are saying? Is that correct? So the formulas are given here. Uh, Here actually you can see if you are opting for example aluminum or iron as the factor. So the concentration of aluminum or iron, whatever you have taken as a background metal in that area versus the actual concentration of the metal. So we are not talking about absolute concentration of these metals but the ratios between these two, and we try to find out this particular index. The reason is sometimes if the soil is such that overall metal concentration is higher, so even if this background metal concentration is going to be higher, so if let us say you are talking about chromium, so we are instead of saying chromium concentration, you are saying fraction of chromium versus iron in the background, also chromium versus iron in the contaminated area. How does they compare? Rather than absolutely saying chromium is high, if chromium is high, let us say, but iron is also high, which is the background, chromium is low and iron is also low, and in fact they are maintaining the similar ratio, we won't say there is a contamination because overall metal is high. So we will not say it is due to anthropogenic reason. It could be because of the geological reasons. So this IGO will help you in understanding whether the pollutants are artificially contributed by the human activities, or is it because of the natural accumulation of these metals. So for that we use these factors. Is the concept clearer?
Yes,
See,
sir,
for
it's clear. And sir, I had one
I
more
would say
question.
I would give a parallel example of air quality if you allow. See, for example, if you
Yes.
go to Rajasthan and monitor the concentration of dust particles, you will find very high. Am I right? Because it's a desert and there is wind blowing, so you will find high concentration of suspended particulate matter. But can you attribute that to industrial pollution? No, it's natural phenomena. So what I'm trying to say is whether it's a natural phenomena or anthropogenic activities, you have to distinguish. So that is where these factors help you. What is the background level of pollution in general versus the pollutant you are trying to study?
Sir, how can we do that similar approach in air quality?
Yeah. In the air quality also, we try to find out the background level of pollution. We try to figure out background level of pollution. So interestingly, if you come to Delhi in summer or if you come to Delhi in winter, you will find the background level of pollution in these two seasons are very different. You will find dust storms in Delhi in summer because it is only 150 kilometers to 200 kilometers away from the Rajasthan. You will find dust storms in Delhi, but suspended particulate level is very high. But you cannot say this is due to vehicles and industries and so on and so forth. It is actually due to the desert storms. So background concentrations are uh, calculated and then reported by the meteorological departments. Similarly, in winter, you will find very different background concentrations. You will find most of the time the direction of wind and other meteorological factors will matter a lot in finding out even the background concentration. In case of soil, normally background concentration once you have found will not vary much from one season to another except for a flood affected zone. Pre-monsoon and post-monsoon background levels are going to be very different. But in air quality, we have different background concentration for three different seasons. Summer different, winter different, monsoon very different. Because the direction of the wind changes, the kind of pollutants. This is also very important for the coastal cities. So if the wind direction is from the sea towards the land, you will find even sodium and chlorine ions in the wind. And then you will find the pollutant concentrations very different actually there. Humidity matters and so many factors matter. So background concentration becomes very important part. In order to really understand, the contribution is due to anthropogenic activity or due to natural activities. Right?
Sir, I had one question. Sir, you
Please.
are showing only pre-monsoon and post-monsoon data. The monsoon data are not taken.
Yes. So monsoon conditions was very uncertain for us because if you go on a particular day during monsoon, for example, I'll say first week of August, if you go, that time there is heavy rain. Okay, and after that for 2 weeks there is no rain. So data will vary so much that we will not be able to make out anything during the monsoon. So because every day is a different day in monsoon, na? Some day there is a too much of rain, some day there is no rain, some day there is a rain after 10 days. So we don't want to be misrepresenting that by seeing that this is either a spike or outlier kind of thing. So we wanted to be careful in terms of reporting the monsoon. That was the reason.
Okay, sir.
Because
Thank you.
monsoon there are so many things happening, na? So many changes happening every day. Right.
Thank you, sir. So anybody else who would like to interact with sir? Sir, I cannot see any further questions, and if they are arisen by the participants, I will share it with you over the email.
Absolutely. Thank you. Really.
Thank you so much,
So
sir.
thank
Thank
you
you,
so
sir.
much. I enjoyed talking to the people, especially when the audience asks questions. We are happy. Really. Thank you so much.
Thank you, sir.
Thank you,
And
sir, for taking out time from your busy
see,
schedule.
I could see close
And
to 100 people logged in. So it's honor to me. Thank you so much.
thank you
Thank you,
so
sir.
much, sir.
It's very big number logged in. So I'm really happy. Special thanks to you, organizers.
Thank,
Thank you.
thank you,
Thank
sir.
you,
We
sir.
would
Thank
love
you.
to have you in person next time.
Thank you so much.
Thank you, sir.
Thank you.
The next session will be starting at 3:30 p.m. So we will have a break of 10 minutes and we will be back again.
घर पर ठीक है सब लोग अमित?
जी जी सर, बाकी
A
सब
very
बढ़िया
good
सर।
afternoon.
हाँ एकदम।
Sir, shall we proceed, sir, with the
या
introduction?
या
Very good afternoon, sir. Welcome to the AICT sponsored 1 week online short term training program on water quality complication, restoration, and environmental conservation of existing water bodies, Module 1, on behalf of Civil Engineering Department of IPS Academy, Institute of Engineering and Science, Indore. I welcome Dr. Narulkar, sir. He will be taking the next session of day 2 on maintaining water quality through water harvesting. Dr. Narulkar is a professor at the Department of Civil Engineering and Applied Mechanics, Shri G.S. Technical Institute of Technology and Science, Indore, presently in charge of water supply and sanitation of the institute. He has graduated in civil engineering, postgraduate in water resources engineering, and a doctorate in civil engineering. With an expertise in water resources engineering, water management, hydrology and hydrologic modeling, he has 66 research publications that includes articles in journals and conferences, 83 postgraduate students guidance, 11 PhD students he has supervised, 5 books has been published, 2 research projects he has been working on, which have grants from MPCST, Bhopal and DST. He is the member of Reservoir Operation in River Narmada constituted by the Narmada Control Authority Indore, Sustainable Mobility Project for Indore City, STA for MP Rural Road Authority, RG Watershed Mission in Indore, and Modernization and Capacity Enhancement of Yashwant Sagar Dam. We are honored to have you with us, sir, and thank you for taking out time from the busy schedule and enlightening us with your inspiring words. I request you, sir, to please proceed with the session. So you can share the screen now, sir.
Yeah. So today's topic of our this thing is maintaining water quality through rainwater harvesting. Basically, this is one of the very important and very hot topic in these recent days, wherein a lot of people in India as well as abroad, they are interested in rainwater harvesting, understanding and mechanisms and processes involved in the rainwater harvesting. So rainwater harvesting is basically a typical thing, typical phenomena, particularly in India, because rainwater, जब हम इंडिया के context में बात करते हैं, when we are talking about the Indian context, the rainwater is the prime source of water, and its occurrence is typically uncertain and variable, because many a times it occurs in ample quantity or very heavy rainfall, and many a times it doesn't occur at all, and for 15 or 20 days people have to wait. The average precipitation is not even the average precipitation is not achieved. So uncertainty और variability, ये दो चीजें इंडियन रेनफॉल के साथ बहुत ज्यादा बड़े पैमाने पे associated है. Then it varies spatially, that is over the space, and temporally, that is over the time, because sometimes you see that IPS Rajan Nagar ki taraf there is a rainfall, and then you see that in the city there is no rainfall. So it's typical because its occurrence is not uniform, so it varies spatially as well as temporally. Over the time also it varies. Then uncertain in quantity because excess of it harms. यदि बहुत ज्यादा गिर जाए तो फ्लडिंग होती है, इसलिए excess of it harms, and dearth perturbs, मतलब यदि पानी कम गिरे तो बहुत ज्यादा प्रॉब्लम खड़ी होती है. So Indian rainfall scenario is well explained in above lines. It impacts the socio-economical as well as political scenario widely. Our governments, they fall or they gain mileage in the year when the monsoon is normal or above normal. And as soon as there is a drought condition, obviously the governments fall or fail to get themselves re-elected. So it is something which has socio-economical as well as political scenario impact on both the things also. So the country's agricultural produce depends primarily on the rainfall, and a failed monsoon destroy the farming community and setback to the national economy. The principal cause of poverty and recurrent suicides of farmer is in majority areas of the country is vigorous monsoon. During monsoon, the rainwater passes through drains and rivers like a superfast train, keeping the landscape high and dry. Post-monsoon situation, less water, surface water, dry rivers and dry wells. What has to be done? The solution is rainwater harvesting, which has a tradition of Indian civilization. So rainwater harvesting is perhaps the best solution to bring water to the landscape. So let us see that rainwater harvesting is the collective term for a wide variety of interventions to use rainfall through collection and storage, either in soil or in man-made dams, tanks or containers, bridging dry spells and droughts. The effect is increased retention of water in the landscape, enabling management and use of water for multiple purposes. That is the most important thing, that if we are doing lot of rainwater harvesting, then we are getting lot of water available in the landscape in the surrounding areas. The basic aim of the rainwater harvesting is to reduce the speed of the flowing water, that is runoff, and storing more water in the landscape, that is the watershed, to enhance the soil water and groundwater storage for use in the dry season. Monsoon delays or long gaps or deficiency. So हर चीज की gap भरेगा. So that is what is basic uh, advantage. And the whole same thing is written by United Nations Environment Program. By retaining landscape water flow, increased rainfall infiltration, increased growth of vegetation, and decreased soil erosion, surface runoff, and incident flooding. बहुत सारी बातों में चेंज आ जाता है यदि आपने अच्छी तरह से आपकी वाटरशेड में रेन वाटर हार्वेस्टिंग कर रखा हो. सो दैट बिकम्स ए ग्रेट ग्रेट लेवल ऑफ अंडरस्टैंडिंग कि हम वेजिटेशन ज्यादा बढ़ा हुआ देखेंगे, सॉइल इरोजन कम हो जाता है, सरफेस रनऑफ भी थोड़ा कम होता है शुरू में, वो यूनिफॉर्म होने लगता है पूरे साल भर क्योंकि बेस फ्लो नीचे से आने वाला फ्लो ज्यादा हो जाता है. और ऑकेजनल फ्लडिंग, इसको इंसिडेंस फ्लडिंग उन्होंने ऑकेजनल फ्लडिंग के लिखा है. Then rainwater harvesting is done either naturally or artificially. It has to be, it has two things. One is it is done either naturally, if by some natural means, or by some artificial means. The benefits of rainwater harvesting are: first is increased water availability for multiple uses, reduction in flood, reduction in soil erosion, increased groundwater storage, better water security throughout the year, drought proofing, increased green cover, thus better climate change resilience, more employment opportunities, and many more. Because employment opportunities matlab more industrialization, more commerce means more money, more economics. So that is all going to be a joint effect of what we do in the form of rainwater harvesting. So traditional rainwater harvesting in India is very important to study this part, because in general what happened that in the old days when there were no pumps, there was no electricity, there was no powered engines or nothing, but still people lived through the ages. And those ages, people living in those ages, they knew that those the importance of water harvesting and storage, so they did it. So the ancient civilizations and kingdoms simply vanished due to the vagaries of monsoon, and communities had to shift from one place to another, but there were still live traditions to retain water and harvest it for future use. The wise kingdoms and native wisdom of the people in India have created a wonderful array of traditional water harvesting systems according to geographical and geographical conditions. Now, present scenario: with the passage of time, these traditions were forgotten either or were subjected to modern system of water management. However, in recent times, lots of people in different areas are reviving the traditions and bringing it back to the practice. The government is also supporting such revivals. A few examples of traditional water harvesting systems are presented. Like, they are step wells. This is the most common scenario in various areas. We call it bowdies in our area, so somebody calls it something else. The names are different, but these step wells are part of Gujarat and Rajasthan and Delhi, also a part of Haryana, Delhi. And these kind of step wells are popularly below the forts of Rajasthan, where they could collect the water, and there was a stratified sandy sandstone layers, and in that they used to collect the water in the form of bowdies and jhalas and so many things. This is another step well. This is Khari Bauli scenario of Delhi. Then this is another type of open bowdy, kund, we call it as kund, but there will be steps to reach to the depth of a well. So that is step well, or this, because there are steps, so we call it as step well. Okay, so that is one of the major things. Then talab, bandi, nadis, pokhar, pukur, sagar, samat, kere. Kere is Karnataka, pukur in Bengal, eri area in Andhra Pradesh and Telangana, Jheel, then Tal, Talaiya, Tale in Maharashtra they call. So they are all old style tanks, water tanks. They are getting stored into this water. This is Jahaj Mahal, close to the Jahaj Mahal of Mandu. So, and this is somewhere in Rajasthan. So these are all talabs and all. Then Rajasthan again, we come to the Rajasthan deserts of Rajasthan. So they create a taka, and this taka includes the water flow, and you see that the passage of water, because it carries some silt and sand from the flowing water, because in Badmer and Jaisalmer districts of Rajasthan, the rainfall is almost in the range of 3 inch to 9 inches or so, and whatever water comes down, there is an underground tank which is connected through this opening here. The water in this area, which is shallowest point, so there is a tank like construction all around, and then water comes up, and naturally it flows through this passage. This serpentine passage will ensure that lot of sediment which it carries gets settled into the this thing, and then finally pure water will go inside. Since this is a sandy soil, so there is no problem, and that works well. So that is there. Then johars, they are created on the hill slopes. They are very small earthen dams, and the water is filled up into that. And these johars are of temporary nature, because what happens that when the water comes through in these johars, the soil, particularly in the Rajasthan, is very permissive type of soil. Means it has lot of permeability, tremendous permeability. So what happens that when this water is collected into the johars, up to whatever point it is filled up, people enjoy with that water. There is a spillway arrangement also, because excess water will be collected into a downstream johar. But it has a major advantage of getting percolated into the ground and then flowing horizontally into the ground, because just below there will be hard rock strata, and that hard rock strata will allow this water to flow down, and there will be wells downstream here in the urban area or in the village, whatever you name. So that johar, a series of johars are constructed, and these johars have been revived in Alwar district of Rajasthan. These johars have been revived by Mr. Rajendra Singh, who works for water. So these johars have played a lot of good role in making the rivers in that area, which have started flowing throughout the year. So that is one of the major advantage of such kind of structures, which are created for in the Rajasthan area. Then there is a Khadin system. It is not exactly at the hill slope, but in the plain surfaces, over the plain surfaces that is created, there is a masonry or earthen bund created, and the water is getting collected into that, and then it is same serving the same purpose as George, in which the water percolates and comes down to the wells. So wells are filled up throughout the year. So Khadin system is also very much popular. It is Dhora Khadin. It is in the western Rajasthan as well as north part of Gujarat, north and Kutch part of Gujarat. So the Khadins and Johars are created. Then this is a Nagaland area. That is what happens that despite of the fact that the state of Nagaland receives maximum rain in this country, because Shillong, then Cherrapunji, and another one more village has now arisen where maximum rainfall occurs, world's maximum rainfall occurs. But still, in the dry season, these people face tremendous problem, because this whole state is a hilly state, and the hill slopes they offer a proper passage for water to flow down, and then through the drains it goes down into the Ganga river in Bangladesh, which we call it as Padma now. In Bangladesh it is called as Padma. The branch of Brahmaputra and Ganga, when they meet each other, they call it as Padma. So this water all goes into the that rivers and goes to the sea. So but they create the zobo or ruza. So runoff is impounded in a specific tank, and you see that there is a paddy cultivation. That is main principal diet of East India. People eat rice more than anything. So that is they irrigate it through this. So water will be flowing through one field to another field and so on, and that way it will be advantageous. So that is in Nagaland. Now we come to the extreme south in Wayanad. There is Kumar tribe which uses a special well because there are a lot of underground streams. So what do? They do is they dig into the soil, and then what do? That they use some tree barks of toddy palm, जिसमें से टाड़ी बनती है, उस टॉडी पाम के बार को फंसाकर उसका पूरा एक वो बना लेते हैं, और उसमें से ये नीचे से पानी it comes out above, and then that water is used. So these cylinders 4 feet in diameter as well as depth are then immersed in groundwater, and then ground springs में से पानी काफी आता रहता है, तो इसका भी एक फायदा है. देन जिंक्स ये लद्दाख में उगाते हैं. लद्दाख में वो क्या करते हैं कि मेल्टिंग आइस के पानी को इकट्ठा करते हैं, एंड देन दे यूज इट फॉर कंजर्वेशन पर्पसेस. Then in Maharashtra there is a FURD system. FURD system was basically created by the Indore queen, that is Ahilyabai Holkar. In FURD there is a small dam created across the river. This is a modern FURD because it is created through RCC, that is cement concrete, but it used to be getting created by the masonry structure, and then there was a gate to seal that, and the water will be filled up, and then that water will be driven through this FURD to the irrigation areas. Then part system, FURD and part are more or less the same. The only existing part system is in the village Bitada in Jhabua district of Madhya Pradesh. Now this district Bitada has come in Alirajpur district. It is very close to the river Narmada, and what they have done is that they have created a rock-filled dam here, and then water is allowed to flow, and then there are canals dug. So that is also one of the things, but it is generally done in the plain surfaces. It is not an option, good option for hilly areas. So that is one of the things. Then Khuls. This is specifically in Kangra Valley of Himachal Pradesh. Again, Himachal Pradesh also is a wet kind of state in which lot of water is created due to snow melt runoff. But what happens that during the non-monsoon season, the water has to be diverted to the fields, and then they create khuls. And khuls are diversion structures in which they are surface water channels that carry glacial waters from rivers. जो पानी पिघलता है ग्लेशियर पिघलने के कारण जो पानी आता है उसको डाइवर्ट करते हैं, एंड देन दे टेक इनटू द फील्ड्स, है ना. तो 715 मेजर खुल्स एंड 2500 minor khulds, that is irrigating more than 30,000 hectares. It's a big thing. Then ahar payans are in Bihar. What happens that there is always a flooding. So what happens that they collect the water into these ahars, है ना, ahars and pines. So they collect this water into this thing, and then they use it for irrigation. So the flooding water, when that gets down, that is collected in this kind of ahars, and that is and pines are artificial rivulet. मतलब जब पानी आएगा, पाइन्स मतलब आर्टिफिशियल रिवुलेट जो क्रिएट की जाती है रिवर से पानी को लेने के लिए, और आहार्स मतलब ये जो ऐसे लंबे लंबे कैनाल टाइप के स्ट्रक्चर बना के रखते हैं, आहार पाइन्स. देन again bamboo drip irrigation system is northeast India's, this is in Nagaland, in which the water is brought from the bamboo, this thing like rooftop water is brought in a bamboo pipe, half pipe bamboo, and they are connected in such a manner that you can now irrigate it, and there are holes created down below this flow pipe, and then these holes will irrigate. So that is basically a old traditional technique of irrigating through drip irrigation. So that is one of the things. Then Great Nicobar Islands, which is surrounded by sea from all the directions, so water is generally very much saline in the wells, etc. Now, in order to protect that and create a freshwater resource, what do? They do is that they carry the bamboo pipes from jungles. There are bamboo canals embedded in the ground, and that large size pipes they bring it to the wells, and that is called as jackwells, they are called jackwells, and they are cut bamboos से बनाया जाता है, and then that is जो पानी के पेड़ों पे जो पानी गिरता है और उधर से जो नालियों में आता है, वो सब नालियां बनाकर यहाँ पानी लेकर आता है. So that is this is so we feel that this traditional water harvesting structures, though storing much less water in comparison to what we feel and what we see now in the modern era, where we construct very big dams like Indira Sagar or Omkareshwar or Sadasar or whatever. But these traditional techniques were able to satisfy the need, local need of the people who were doing their jobs of saving water and then using it using it throughout the year. So that is one important thing. But modern learning and understanding, we have forgotten the treasure. It is requested to all participants to accept the fact that each of the villages has a history of water harvesting in itself. Let us first find best harvesting practices in each village and then proceed for training the people for creating a water harvesting system in a traditional manner. So that is perhaps the best way to understand. Then rainwater harvesting of modern techniques. The basic thing is natural rainwater harvesting, which we go for. So natural rainwater harvesting is accomplished mostly by the vegetation cover. जितना अच्छा जंगल होगा उतना ज्यादा rainwater harvesting होगा. But the mass deforestation and denudation of the slopes has hampered this process in many of the otherwise fertile and fertile land. है ना, वो एंड हो गया fertile land. Otherwise fertile होती थी, अब वो सब खत्म हो गई. Managing water resources in the landscape is thus management of the permanent vegetation cover to enhance biomass production for fiber forest products and to enrich landscape biodiversity. Although forests and trees consume rainfall, they also safeguard and generate many ecosystem services for livelihood and economic good. But they still, now you see the denuded hill slopes. What will happen? Water falling on these hill slopes will just come in a very fast manner. Its speed will be extraordinarily high, and that will come reach the valley very soon, despite of the fact that you are seeing the valley to be greener, but the hill slopes are drier, always they are dry. So that is another. And you just see the vegetation on the water conservation, means you see the forest and the grasslands are grown on the hill slopes, and you see that there is lot of water stored in this storage unit, and water will come slowly. So that water will be available for use throughout the year, instead of filling it once in a time or once in monsoon and using it for whole year and losing lot of water. In the Indian context, many people lose lot of water. Many irrigation schemes lose lot of water due to evaporation, and because of evaporation, at least at an average in the whole country, we lose 1.8 meter depth of water almost in an year. So that is very typical. It's interesting but typical, and we should be able to control and uh, conserve the water. That's what is the aim of rainwater harvesting in some way. So natural one are the best options. That is, you grow as many trees as possible, as many places as possible, because I will tell you the advantage of this at a later stage when we will come to the water quality. So I'll tell you it later, to you later. Okay, so now what can be done? The slide with denuded hill is indicative of heavy deforestation and extraction of mineral resources. The soil depth appears to be so less that rejuvenation of the forest on this land will not be an easy task. For that, we have to apply certain simple engineering measures along with plantation for the vegetation, plantation of the vegetation from tiny grass to bigger trees to hold the soil, followed by water also. The structure suitable in various slopes ranges to protect the erodible soil and enhance the soil cover have to be chosen according to topography, geology, and other things. Is it not? So So now coming to the artificial rainwater harvesting. Artificial rainwater harvesting is done either through agronomical measures, like we create fields, farms, and in such a manner that that also is used for soil and water conservation. Agronomical practices, what I mean to say is that आप crop कैसे grow करते हैं, किस तरह के irrigation method apply करते हैं, उस तरह से आपका agronomical situation बदलेगी, तो पानी के harvesting की situation भी बदलेगी. So that is one of the major things. In soil and water conservation, the agronomical measures is a more economical, long-lasting, and effective technique. Engineering measures too are very important, since they alter the topography and geomorphology for collecting more water. In a watershed, both the regimes are to be blended to get maximum advantage. So that is one of the methods. Now, agronomical measures, we'll see the photographs. We are not interested much in dealing. So what do we do? Like contour cropping. If you have a sloping land, then you crop it in a contoured manner. So that will be retarding the speed of the water on the slopes. If there are slopes are steeper, then if you grow the crops in a contour fashion, means joining the same level, then obviously there will be a lot of water conservation, and it will reduces the runoff speed, and soil will also be trapped. It will not flow along with the flow, because had it been a simple slope, then much of the soil would have been lost due to the erosion, and as a result, that would have created denudation of the hill. So hills would be then strip cropping. You just crop the strips, crop in a stripped manner, and two crops together. One is this, another is left fallow. Presently, it is left fallow because they are growing some grass or some fodder for the animals. So that is there. So one is the crop which is sown. This is perhaps the maize, and this photograph is from America, United States of America. So that will also conserve a lot of water, such kind of strip cropping. Then coming to the next, that is broad beds and furrows. So these are the beds on which the crops are sown, and these are the furrows which are dug throughout, so that water will flow into these furrows, and this water will be entering down below the ground, and evaporation loss, because when we irrigate any field, we know that there is lot of evaporation loss directly, because if we fill up the water into the whole field, that is in the form of ponding, then there is lot of evaporation loss and infiltration loss. But instead of that, if we are allowing it to flow through some furrows means simple drains, they are created with the understanding of the slope of the land of the farm, and then sow the crop on the peaks, and then furrows carry the water. So irrigation is not directly done just at the bottom of the plant, but its side, and the water will reach to the root zone through these furrows. So that is broad beds and furrows. And then mulching is one of the options, in which the earlier grown crop is just flattened on the ground, and then water is allowed to irrigate. So this will also reduce lot of evaporation, and it will also reduce the moisture stresses, because जितना पानी हम इस grass में दे देंगे, ये फूली रहेगी और इसमें पानी रहेगा. So that will be capillary suction से soil इस पानी को खींच लेगी. So that is mulching is one of the major measure. Then pasture cropping. आप जब क्रॉप कर रहे हैं तो जहां भी आपकी स्लोपिंग लैंड है वहां आप पास्चर बना दीजिए. जैसे ये पशुओं के लिए लगा दिया वहां पर चारा. सो पास्चर क्रॉपिंग करने से भी, और लैंड फार्मिंग मतलब हर एक फार्म के लैंड पर एक हिस्से में पेड़ लगा दिए जाए तो वो बेचने के काम आते हैं. कई किसान अपने यहाँ इंडिया में पंजाब एंड हरियाणा एंड देन कमिंग डाउन टू कर्नाटका एटसेट्रा, दे डू सम काइंड ऑफ वुड. जैसे पंजाब में वो विलो के वो लगते हैं ट्रीज. आप अंबाला कैंट पार करेंगे तो पंजाब में लगातार विलो ट्रीज मतलब जिससे बैट बनते हैं हमारे क्रिकेट के, तो वो ट्रीज प्लांट करते हैं. या मैच स्टिक बनती है, वो दूसरे टाइप के विलोज उसको प्लान करते हैं और वो बेच देते हैं साल 6-8 महीने में, 6-8 साल में, then that is cut again and then again grown. So this also conserves and holds lot of water. then growing woodlands on the fields. That is one of. Then engineering measures are very typical. That is trenches and bunds, bench terracing, gully plugs, check dams, stop dams, bandaras, nala bunds. Cheaper options are gunny bag dams. There are a lot of things. We'll see pictures of one by one and just try to understand next. Then engineering structures intervention, जो कि स्लोप साइड फुटहिल डक पॉइंट्स है और सब सरफेस डाइक्स है और ये सब मैंने आगे एक्सप्लेन किए हुए हैं. अपन आगे बढ़ते हैं. नाउ पहाड़ी ढलानों पे in the on the hill slopes, steeper hill slopes, the trenches are done. They are continuous kind of trenches. That is simple nali, और जो whatever excavated material comes out, that is laid along the downstream side of the trench, so that that will act as a bund. So trenches and bunds. Now they are inline trenches. The trenches are dug at distances, and the water will come, get intercepted in this, then flow here, then intercepted in this, and so on. So that is non-continuous but inline trenches. And then there are staggered trenches in which the water coming through two trenches will be collected in the third trench, 1 and 2, and this is 3. 1 and 2, and this is 3. So that will be creating another retardation in the speed of the flowing water, and none of the water drop can just go directly without entering into any of the trenches, which reduces reduces velocity of the flow in a tremendous quantum rather, I would say. Then contour trenches are dug along the contours, and they are also continuous trenches only, but contour trenches. So these are the four actual pictures. That is, these are the continuous trenching, then inline trenching, one below the other, then staggered trenching, these two, and then these two, and then this, and so on. And then there is a stone boundary, stone hedge created. So staggered trenches, and then this is the contour trench. Yeah, this is contour trench. The trenches are dug along the contours. They are also contour trenches only, but they may be going down or up. There is no restriction of following a contour, but here they have to follow only the contour position. Now, ये जो ट्रेंचेस होती है कंटिन्यूअस ट्रेंचेस, इसमें कैसे होता है, ये ट्रेंच खोदते हैं और जो एक्सकेवेटेड मटेरियल है दैट इज कमिंग आउट हियर, एंड देन अ बंड इज क्रिएटेड बाय कॉम्पैक्शन. So whatever water is overflowing this bund will be collected into the next trench, and so on and so forth. So that then staggered trenches also, their position and some dimensions have been given here. Then comes on the much a steeper slope, there is bench terracing. Bench terracing is a process through which we try to get into farming as well as the stepping. So at every horizontal this is bunch terrace, this we call it as terrace, and this is encircled by bunds, so that whatever water is flowing will be collected into the field and will be having more infiltration opportunity. So that will not cross this bund unless and until that is getting filled up. So somewhere you have to dig a small hole at some level. So as soon as the required depth in the whole terrace is filled up, then obviously that water will spill down to the next, and then spill down to the next, and so on and so forth. So bench terracing. Then gully formation. On many of the hill slopes, you might be seeing and visualizing that there is a formation of drain, a small drain which is irregular, which is having mostly the irregular shape, and that we call it as gully, Gully. And this gully formation, you see how severely eroded land, hill slope is there. This is the plateau land, and there is a hill slope here. There is another hill which is getting eroded just right at the top of itself, and then getting into the problematic situation because there is lot of gullying. So these gullies then eventually comes into the form of ravines, है ना, बीहड़ बोलते हैं जिसको. और वो बीहड़, यदि यहाँ पर बीहड़ बनने की प्रक्रिया शुरू हो गई है, they have started getting into connected into the deep valleys with each other, and they will be connected in a complicated manner, so that you cannot even understand that how topographically how to move within that, and how the water is getting moved. So that is ravines, है ना, बीहड़ बोलते हैं जिसको. So they create lot of ravinous land. So for that you can have gully plugging. This is loose boulder dam, a loose boulder gully plug, and this is gabion. Gabion means it is a box in which a box created out of a net which is covering the stones, so that in this case, if the water runoff is having more velocity or more speed, then that will be dislodging this, and this may break. So the loose boulder gully plug never works for a longer time. So instead of that, you create, ये गली बन रही है, तो गली की शुरुआत हुई है, वहां पर आपने गली प्लगिंग के लिए ये गेबियन स्ट्रक्चर डाल दिया. अब इसका गली का रुकना बंद हो जाएगा, और ऊपर से जो इरोडेड मटेरियल आ रहा है, that will be getting stored into the earlier gullies, and the next gully plugging will do the same job for this. So that is what is gully plugging. Then check dams. When talking of check dams, that is created on the plain surfaces, all the drains or nalas are created. So this is one of the economical way of doing the water harvesting. That is, this check dam is created in an arch manner. So what do? Is that they create the foundation, and there is one single layer of the reinforcement, and then they put stone masonry around that. So now this reinforcement imparts the strength to the material. So, and the plain concrete layer is exhibiting the foundation, in which there is small reinforcement cage is put, so that that will not be getting drifted unnecessarily. And another thing is that that should not get washed off and all. So what will happen, that now you are using this, and then these stones are kept here, and then that will be creating a masonry structure like this. Final creation, this is construction and this is final creation. You see that how much water it is stored. So the farmer, besides this, will be benefited. Nowadays we have a lot of pumps, so you can put the pump, and pumps always serve. Pumps pumping from the surface will be less energy consuming in comparison to the pumping from deep underground. So water conservation and water harvesting teaches you to conserve the energy also. So directly or indirectly, your energy is also getting saved or consumed in a proper manner. So that is one of the things. Then there are many cheaper options in which some locally available material is used. Now this is gunny bag check dam or nala band. है ना, कोई भी टाइप का बंड अभी स्टोन अवेलेबल नहीं है जिस जगह पे. सो व्हाट डू? You take these gunny bags, and these gunny bags are available in ample quantities in villages, because most of the villagers are now using chemical fertilizers and other chemical additives which are used for growing more crops. So these chemical fertilizers, etc., the bags of those chemical fertilizers or cement bags are filled up with the sand or whatever soil which is available in the surrounding, and they are laid in a masonry fashion, like one over the other, two and then one, and this fellow is standing on this. So that is a masonry arrangement, and that is creating a dam kind of structure. It is a temporary but cheaper options, because it is available from the locally available material. So this is one of the best cheaper options. Then gabion check dam. Gabion check dam is again the gabion structure. You see the iron net, and within the box, and the boxes are created like this. They are rectangular boxes. First the iron net is laid down, then that is turned. It comes into the form of an open box. In that open box you fill up the stone pieces and particles, and then fill it up, and then close the box. So one gabion laid over the other, one gabion laid besides the another. This is this gabion structure, and this top gabion structure is laid over this. So this will not be dislocated and displaced due to the force of water. So that is also one of the major thing, in which the rock mass or the locally available, because in the river beds there are a lot of alluvial material which are coming along with the river from its hillside, and they are getting dragged into the bottom surface of, over the bottom surface of the river. So that creates enormous changes. So that is one of the major things which we see here. And so that is, we call it as a Gabion Dam. Then comes the earthen dam. It is very common earthen dam, common type of dam. Earthen dam you create across any channel. You create an compact earth and create an earthen dam structure, and then have stone pitching done, and then that will be done. Anyway, government of irrigation department, they also are doing the same thing. This is a dam which is created in Jhabua, where I work for rainwater harvesting with the people, tribal people. I always train them for creating small bunds, small earthen dams and bunds. So that is one of the major thing. And there is cross section. So we'll see on the next. So then talab or pond with earthen embankment dams. This is very common because most of the villages in India, they had their own talab since the kingdom period, and those talabs are maintained and used nowadays. So that is this section, that this is earthen bund created. This is a very big dam, but this is a very small dam which I just shown. This is a dam with a height of, now this lady is standing, so she is of 4 feet, so you can say that it is just 6 to 7 feet, 7 or almost 8 feet. Suppose we can say that this height is double of her. So 8 feet height, that is 2 meter height bund is created, but this will store, and they excavated. This is a mistake which they have done. Just close to the foundation of the dam, they dug the material and then put it like that. That will not be a safer option, and then this will be creating lot of permeability issues, because जैसे हम खोदते हैं, there is possible that the weathered rock will have more permeability instead of the soil which was existing earlier. So that may create lot of seepage down below the structure. So that is not desirable, this kind of digging. But instead of that, if you dig it at least 10 times the height of the dam, then you will have a proper digging material source also will be available, and then you can create a safer dam. So that is now this is one of the things like in which there is a core which is impermeable, and there is a shell which is permeable. So this is downstream slope and this is upstream slope. Downstream slope is steeper and upstream slope is flatter, and this is how they create the water storage. Now this is the dam which has been created by the tribals themselves in the Jhabua district of Madhya Pradesh, and this is the spillway they have created on this side. So that is one of the very important uh, aspect of rainwater harvesting. Then farm side pond. In recent time, they call it as, the government of India has given a scheme in which they call it as Balram Talab, and Balram Talab is just beside. Some of the land of your agricultural field has to be devoted for this. Now, this is an open well type of structure which is dug to the permissible limit, whatever permissible limit which can be seen, that no porous rock mass should be exposed, otherwise the water will get seeped into that. This will act as a percolation tank. So we don't want to lose the water. So what do we do is that we dig the pond, and this pond is getting this embankment created just from the dug material, so that there will be lot of water stored and you can pump it. So farm side pond. Then hill slopes, at the junction of hill slopes and the plain land, if you dig such ponds, there will be lot of water throughout the year, because whatever water which is coming as a base flow from the hill slopes, that will be getting collected into this, and then this will be extraordinarily it is possible in the extraordinarily drought situation even, that your water will come out fast into these things. Then subsurface or underground dams. Many times what happens that your main structure of the dam should be created down in the downstream portion, matlab below the depth, below the surface of the river, because a lot of water flows below the surface. So if you are creating a dam below the surface of water, then upstream area will get lot of water. So you dig a small hole into that and you will get lot of water. So subsurface dikes or underground dams, they call. Then artificial potholes in nala and rivers. You might have heard the story of Krishna, in which he killed one of the snakes, whose name was Kaliya. So Kaliya Dahe, है ना, Kaliya Deha. Kaliya Deha means what? Basically Kaliya Doho, Doho बोलते हैं उसको. Doho मतलब नदी, when the river flows, all of a sudden there are potholes created into that. You can see at present also, when the water is at a very lower level, then in that case you will see lot of natural doors in the rivers. So instead of using the natural doors are always welcomed, because they make water available for conservation purposes even during the non-monsoon seasons. So that is welcomed. But if you want to conserve water from your side, then you can create artificial potholes, doors in the rivers. This doors have advantage that it is contained within the boundary, so there is no land acquisition requirement. Then there is no requirement of any structure, because the dough is created within the riverbank, so you don't have to construct any structure. And another thing is that evaporation loss is also very less in comparison to surface water bodies, other kind of surface bodies, water bodies which are created. So that is one of the major things which advantage of this dose. So that is one another thing. Then stone barriers and earthen barriers. Many a times the fields are unguarded. Our cropping pattern changed from old traditional crop. In Malwa region, we used to sow the maize or the sorghum, that is jawar, makka and all. But when soybean came, soybean crop made these burns to get vanished. In topography of Malwa region like Indore, Ujjain, you see that now the fields are seen distantly, long from a long distance you can observe kilometers together. But in olden days they used to be guarded by the stone barriers or some kind of earthen barriers, so that the soil from the field didn't used to get lost, and water used to get consumed in the root zones, because of these burns. Water will be stored temporarily, and then that will be percolating into the ground properly. Now this is cotton crop grown, and they have created steps because of the topography, and then they have created a stone masonry bund, or you can create a earthen bund like this, and then sow some plantation. Like this is the most common plantation which we Kevda, in Hindi it is called as Kevda, vetiver grass. In English it is called as vetiver grass. So that is sown, that holds water very well, holds soil. So this bunds have least chance of getting broken or washed away with the runoff. So that is also one of the important thing, that earthen bunds, if they are created, then uh, uh, they should be overtopped by the vegetation cover, and vegetation cover should always be protecting the flow. Then comes the artificial recharge of groundwater, which is understood by the rainwater harvesting in general. अभी तक हमने जो कुछ पढ़ा, that was only in the fields and in the rural areas. Now we are coming closer to the urban areas, in which we try to create artificial recharge of groundwater. We try to increase the groundwater levels through a system of recharge. Okay, so artificial recharge has many aspects. Like you see now, this is a well here, and the water is brought into this small pit in the form of depression, and then there is a pipe. This depression is filled up with the soil, and then there is a pipe. I'll show you the photographs also later, but that pipe will allow this water to flow down into this, and then the well is filled up with some kind of boulders, then small gravels, gravels, then boulders, small size, then smaller size aggregate, and then sand, so that there will be a filtration and the water will be flowing down, and then that will be recharged. So this is a recharge well, recharge kind of well. Now, open well recharging system, like we see what Central Groundwater Authority permits. The water comes, flows down here. Then there is a primary filter. The water, there is a pipe in the masonry or concrete tank. The water will come down this here in this next tank. Then from there, it will be coming through the weir, it will come to the next tank, and then there will be a filter device, and through this filter the water is allowed to flow into the well. So there are three tanks. One is filled up completely with the sand and the granular material, and the second one is empty, but it is acting as a water storage temporarily, so that the floating impurities will be getting settled down, and the water is collected from the above portion, that is weir. We call it as weir. Over this, the water will flow down, and then that will be passing through a filter and then going to the well. So open well recharging system is also one of the aspects in which the road water collected from roads, water collected from the fields, and water collected from any kind of land use can be filled up. So that is one of the see, this is the picture, actual picture of this. This is the water which is coming out of the filtration bed earlier, and then this water is getting directly flown into the river, and these are the two tanks. This is the permeable area which I had drawn. So this is one of the demonstration place for artificial open well recharging system in artificial manner. Then tube well or bore well recharging. This bore well or tube wells are very common nowadays, and so they are used, and a filter is created around that, and then there are holes dug into the casing of the tube well, and then nylon mesh or coir mesh. Coir means coming out of coconut fiber, that is coconut tree fiber. Those fibers are set around this. Then there is nylon mesh here also, and there is a filtering device, so through which the water goes into the tube well. So that is tube well or bore well recharging. This is the process which is going on. They have dug a well around the bore well. This is the casing going down, and then they have he's warping it with, there are holes made, and he is warping it with the nylon mesh, and then this is warped one, and then it is filled up with the boulder. Then it is filled up with the different filter materials, and now it has been filled up to the full level in which the sand is there. So water will come and get collected around this, and then it will flow through these holes into the ground, and naturally surrounding ground also it will directly flow down. So that is also, that is one of the another way with which the water is getting borewell recharge also. So recharge shafts are created. This is borewell. Existing borewells or defunct borewells are used for recharging. Then borewell recharging, then recharge shafts. Intentionally shafts are created, and the water is allowed to flow through these shafts to enter into the groundwater storage area. Then the ferro cement tanks. Ferro cement tanks are created to collect the water. This is particularly occurring in the Ratnagiri and other Konkan area district. Whatever these areas of the Maharashtra, coastal Maharashtra, that receives that is one of the maximum water receiving areas. But despite of the fact that they receive rainfall in the order of 2000 millimeter or so, they do not have water in the summer seasons or non-monsoon seasons. So for that, what is done is that there are ferro cement tanks are created. Ferro cement is nothing but singly reinforced. Mesh is used for reinforcement, and the cast concrete is cast around that. So mostly it is mortar, not exactly the concrete, because concrete has lot of large size aggregates and so on. So that is like this, and then the tank is created in that one. So that is ferrous cement tank. Then there is rooftop rainwater harvesting process. This rooftop rainwater harvesting process is very simple system, but I'll tell you the caution because we are again going to understand about the quality aspect of the rooftop rainwater harvesting. So we'll see that how it harms and how it spoils the groundwater completely. So all these kinds of water recharging systems are to be done with lot of care, because they are all nothing but creating nuisance to the groundwater. And you can clean surface water by some means or the other, but you cannot do anything once your groundwater gets contaminated. You simply cannot do anything. You cannot handle the groundwater situation. Nowadays in United States of America and Europe, they are trying to retrieve the groundwater quality through microbial injections within the ground, so that they say that bioremediation of the groundwater can be done and so on and so forth. But in India, it is still a far distant thing which we should be careful. Now, it's a very simple system. This is the roof of the building, and the water is collected through the downcoming pipe, and that downcoming pipe will discharge into area. Now there is a recharge pit here. So recharge pit has some filtering arrangement, and the water will fall over that, and then water will percolate into the ground. This is one of the system. This is another system in which the downflow pipe is connected to a temporary storage tank. Then there is a filter, and then there is a pipe which is connected to the open well. Then another type of system in which there is water is coming down, then there is a tank, then there is some small filtering arrangement, and then this water goes into the well. So this is one of the rooftop harvesting. And in recent time, after 2000, year 2000, rather 1997, 98 and 2000 till 2000, there was lot of government sponsored or NGO sponsored rainwater harvesting projects, particularly in the urban areas. So urban areas mein jab rainwater harvesting karne ja rahe hain to kaise? So what do they do is that the water is allowed to flow through this kind of small filters which are created in the old tanks or syntax tanks, in which there is 10 centimeter of gravel layer, then 10 centimeter of charcoal layer, and 25 centimeter of sand layer, and 25 centimeter of gravel layer, and through which the water is collected. In many of the urban areas in northeast, etc., the water directly is getting collected into the tanks. Even in USA, California state of USA is desert, practically getting converted into desert. uh, Last year they received some rain after 4 years of time. And California, you know that it is very famous for Silicon Valley, for its Silicon Valley, and lot of good educational institutes, University of California at Berkeley, and so on and so forth. Then San Francisco, the film industry of United States of America is also situated. So they are also using. So there is, then they store the water into the tanks directly, and these are the filters. This is a horizontal filter, which is popularly known as Devas kind of filter, because the collector in Devas in those days was very much fond of rainwater harvesting. So there is a arrangement that this is the downpipe, and then runoff, first runoff is driven out directly. The second runoff will be coming to this through a pebble, then pebble layer, and then different size of pebble layers are there, and then water will come out and then getting recharged. But I'll tell you later that this will be creating lot of geohydrology problems in the context of the hydrology, the quality, water quality. So that is one of the major things which create a limitation to the groundwater recharge. So that is one of the major things. Now, watershed management. What we discussed in the previous part of my lecture was more or less the independent rainwater harvesting mechanism. Maybe crop, maybe forest, maybe agriculture, maybe some kind of engineering intervention structures, and so on and so forth. So all these things are clubbed together in a watershed. When a watershed is subjected to proper management in which you try to conserve maximum water within the watershed. If we are able to save the water within the watershed itself, then you get lot of resources in the form of forest products, in the form of increased food production. And if the water is available in any of the watersheds in a proper manner, then you are going to develop that village like anything. The people's habit change, the migration reduces, the people, most of the people, they come back, and so on. So it combines the measures that improve or conserve the ecosystem services and functions in the watershed, mainly those related to the improve the increase land productivity and resource efficiency. So watershed management is one of the most major aspects which one can see. So all these things which we have seen so far, they are engineering measures or non-engineering measures to conserve water and then use it whenever or whatever, in whatever way or whatever manner it is possible. But going to the going to few more steps ahead, we know that all this is going to affect the quality aspect of the groundwater as well as the surface water. Now, probably in this course, many of the people might have discussed and narrated about the water quality aspects of water, or water source rather. Now, our water sources are rivers, rivulets, water tanks, and ponds, and wells, that is related to the groundwater, tube wells, etc. And with the intervention in the form of water harvesting structures or in the form of some kind of watershed management, what are you doing? You are practically increasing the groundwater potential in that vicinity, in that area. And that will be creating trouble if you are not properly ensuring the entry of the water into the ground, or entry of the water into the surface water bodies which you have been dealing with, and you have been bringing water from various sources to be stored into the surface water body, even the rivers. Now basically, due to the anthropological, that is human activities, our water bodies now have become contaminated just from their sources till the end. And we know that in our childhood, in my childhood, I am telling, whenever we used to go for picnicking and all, so we used to get water filled up from the nearest pond or whatever, and then we used to drink or cook whatever is there. Nowadays, you always carry a bottle with mineral water either, or water which is filtered and de-hardened and non-saline, made non-saline, and that water is carried by you, whole domestic water treatment facilities, like in the form of some kind of UV filter or some kind of RO or whatever. So that water you carry, you never trust on the flowing water, you never trust on the water which is available in the picnic spot. So you don't never trust, you don't even dare to drink tap water which might be created by somebody, a tap system, overhead water tank, and then there is a tap, and then you can drink water. We used to drink in our childhood. We never used to bother that what is behind the wall of the tank, whether it is having lot of algae or some kind of pollutant. We never cared, and somehow we grew. So that is one of the things. But now everybody has become conscious and cautious about the water quality aspect also. And so rainwater harvesting and watershed management, despite of the fact that they are intended to enhance the water resources in an area and reduce the speed and quantum of water along with the groundwater recharge, thus the flood peaks are reduced and water flow in the channels are maintained more or less at a uniform rate. जो पानी बहकर आ रहा है ग्राउंड में से बेस फ्लो के रूप में आ रहा है, वो हमेशा यूनिफॉर्म रेट से आएगा, कंट्रोल्ड रेट से आएगा। सो एडवांटेजेस अपन ने पहले भी एक बार देखे थे, फिर से अपन एक बार इसको रिपीट कर रहे हैं कि रिडक्शन इन द फ्लो ऑफ वेलोसिटी, enhancement of groundwater storage in the vicinity, reduction in erosion of surface soil as well as nutrients, increased base flow to the river channel, improve the quality of water because of natural infiltration, absorption as well as chemical exchange, reduces the effect of non-point pollution of the water bodies, which is the main concern of the managers, water managers today. है ना? Non-point source मतलब क्या है कि हम खेतों में जैसे यूरिया सुपर फॉस्फेट डाल रहे हैं, या हम खेतों में किसी किस्म का फॉस्फोरस इंड्यूस्ड फर्टिलाइजर डाल रहे हैं. So what will happen that this all will be used by the plants for their growth, but what will happen to the remaining mineral? क्योंकि आज our farmers or our farmer community is not so much aware. If they are getting urea on subsidy basis, they will put it to the whatever possible extent, and then don't care, they will not care that how the nutrient balance in their respective soils of the fields will be getting affected. So that salty water will be flowing through the falling rainfall, it will be getting dissolved into the rainfall, and that will be transmitted through the runoff to the water bodies in the form of pollution, which is not judged, which is never recorded. If you are putting an industrial waste pipeline into the river directly, the difference of the color will indicate that yes, this particular industrial unit is polluting the water. Whereas if you are allowing this kind of open this thing, then there are urban areas in which lot of problems are there. There are fecal elements which are been thrown by birds, or which have been thrown by sheep, or which have been thrown by cows and all. Cow dung also is there. So all this is carried out with the flowing water as soon as the heavy rainfall comes, and you enjoy the things like the things are flowing and they are going down. Your roofs are getting cleaned, your pavement surfaces are getting cleaned, and the mud is going flowing, but that mud is carrying lot of microbial as well as the chemical pollutants. So that is one of the things. है ना? So non-point pollutant, rainwater harvesting, non-point pollution, पॉइंट पोल्यूशन, यानी नॉन पॉइंट पोल्यूशन और नॉन पॉइंट पोल्यूशन दोनों को ही रोकने का काम करता है. सो दैट इज वन ऑफ द मेजर थिंग्स. नाउ यू हैव टू टेक केयर वाटर क्वालिटी एस्पेक्ट्स ऑफ रेन वाटर हार्वेस्टिंग एंड वाटरशेड मैनेजमेंट. ये दोनों बहुत कोरिलेटेड और इंपॉर्टेंट चीजें हैं. अपन ये जानते हैं अच्छी तरह से कि द नेचुरल रेन वाटर हार्वेस्टिंग मोस्टली डन थ्रू वेजिटेशन इज परहैप्स द बेस्ट ऑप्शन. This does not only trap more water but has a capacity to treat the water in a natural manner through its root. You might be studying, many of you might be teacher of environmental engineering, and you might have heard name of phytoremediation. Phytoremediation of sewage. Phytoremediation means using the plants to recover the quality of water, restore the quality of water. So phytoremediation is one of the technique, and if the natural forestation is there, you see that whenever there is a polluted water flowing, the drains will either have lot of besharam trees grown, or lot of other kind of trees grown, which are very commonly grown in the sewage water. Particularly in the case of sewage water, they are grown. So that is one of the best option. But again, that also has some kind of limitation, which I will tell you later. So what this will happen? The agronomical measures are also good from viewpoint of water quality. Then engineering, like I was telling you about the nutrient. What will happen to the nutrients which are spread into the fields, or nutrients which are coming out of the vegetation loss also? So those nutrients get collected into the water bodies, and then water body is full of nutrient. So the water plant, like plants which are able to grow, like water hyacinth or other kind of algae which are grown into the tanks, open tanks, most of the ponds and open tanks. And most of you might have seen most of the water bodies in the polluted areas infested with the algae. And algae infestation is one of the major infestation of vegetation, which will be the water body will lose water due to the tremendous rate of evapotranspiration. The transpiration rate of water hyacinth is very, very high, and lotus flower, that what the transpiration rate is very, very high, and that will withdraw the water at a very fast rate. So that is one of the major things. So we call it as eutrophication, the vegetation growth in the ponds and water bodies in the river and rivulets. We call it as eutrophication of the water body, and eutrophication is nothing but it is resulting from the nutrients which are coming as a runoff solution. So the water itself is a solution, so that comes and joins the water body. So agronomical measures are also good. Then engineering measures also serve. Anyway, but groundwater recharge, indirect way, if you are inserting into that, that is the best option to improve the water quality. But if you try to reduce or try to have a shortcut method or a very short circuit method of injecting the water into the ground, then that will be creating tremendous problems with the water quality aspect, है ना? So roof water harvesting in urban area, rural area is very much harmful. जो अभी मैंने जो फिल्टर्स बताए थे उसमें बहुत ज्यादा वाटर, ये जो है इस तरह के फिल्टर, इसमें क्या होता है कि शुरू में बहुत अच्छा लगता है कि अरे वह पानी साफ होकर आ रहा है, इधर से भी बड़ा साफ होकर पानी आ रहा है, पर जैसे आपकी डस्ट वहां जमा होती है इसके फिल्टर में, इस फिल्टर को हम लोग फिल्टर प्लांट की तरह क्लॉगिंग, डीक्लॉगिंग नहीं कर सकते, इसको अपन बैक वॉश करके और डीक्लॉगिंग नहीं कर सकते। तो इसके ऊपर धीरे धीरे वहां पर ग्रोथ शुरू होती है, बायोलॉजिकल ग्रोथ शुरू होती है, क्योंकि कहीं ना कहीं से आपका बायोलॉजिकली कंटेमिनेटेड वाटर हो ही जाता है, तो वहां पर बायोलॉजिकल ग्रोथ शुरू होगी और वो उसके कारण माइक्रोबियल एक्टिविटी बढ़ेगी, एंड योर वाटर विल बी कंटेनिंग लॉट ऑफ माइक्रोबियल elements in the form of bacteria or in the form of germs, etc., and that will be getting directly injected directly into the area, into your groundwater. So that is one of the very, very important aspect, that you should never practice roof water harvesting in a direct manner. Don't insert water directly into the ground. So if you want to improve the water quality, बात करते हैं अभी तो बस 5-7 मिनट. So improve the water quality, then you can have a blend of all these things together, but your water should never reach directly. So that is, rainwater is relatively free from impurities except those picked up by rain from the atmosphere, but the quality of rainwater may deteriorate during harvesting, storage, and household use. Wind-blown dirt, leaves, facial droppings from birds and animals, insects, and contaminated litter on the catchment areas can be source of contamination of rainwater, leading to health risks from consumption of contaminated water from storage tanks and storage ponds and whatever. There has been a growing interest, especially in developing countries, in rooftop rainwater harvesting as an alternative source of drinking water. Most of the studies reveal that harvested water is heavily contaminated microbiologically by a variety of indicator and pathogenic organisms. Unless special care is taken during the collection and storage of rainwater, heavy metals and trace organics could also pose a problem. हम ही लोग अपने घर का अटाला छतों पे रखते हैं और उसी पे से बहता हुआ पानी आएगा. अब उस अटाले में आपने क्रोम प्लेटेड आर्टिकल्स रखे, वो क्रोम प्लेटेड आर्टिकल का क्रोम पॉलिश उखड़ उखड़ के बहेगा पानी के साथ, और वो हेवी मेटल क्रोमियम और लेड और भी तरह के स्ट्रॉन्शियम वगैरह के रूप में, मॉलिब्डेनम उसके रूप में वो नीचे जाएगा, पानी को कंटेमिनेट करेगा. So that is also one of the things. So references and acknowledgements from where I took my lecture. So, and thank you. Harvest the rain, reap the gains. So that it's true that harvesting is true, but quality aspect have to be checked and seen. Anyway, so any questions are there? You are most welcome with the questions. If somebody wants to ask any questions.
Thank you so much, sir, for such an informative session. we are enlightened by the rich knowledge that you have shared. Are the participants having any questions, sir? And I request you, sir, please switch on your camera, sir.
Yeah.
So now you are visible.
Yeah.
Yes, sir.
If anybody has any question,
So we have a doubt.
yeah.
So actually the terrain in which IPS Academy is, we try to harvest the rainwater which is coming, but the ground is not supporting the absorption. It is rocky sort of ground that doesn't absorb a lot of water. So what
Yeah,
can we
yeah.
do about that?
Some kind of recharge shafts, etc. Are there any kind of defunct tube wells or the
Yes, sir.
tube wells which were not successful? You can use those things also into, you can insert the water through some kind of filtration device and then try to uh, see to it that it doesn't, because what has happened is that IPS Academy is, though it is situated on the sloping rolling terrain from that Hukma Khedi side, and it is situated on the rolling terrain, but still it is situated on the farmland, and farmland in Indore is mostly comprising of the black cotton soil, which is expansive in nature, and the expansive nature of the black cotton soil is making it highly impermeable because of the water. As soon as it is coming in contact with water, it swells, and the porous space reduces drastically. Means the swelling is in the swelling and is in the order of almost 50% in black cotton soils. So that is one of the major limitations. So black cotton soil creates a lot of problem, but you can do something like replacing some uh, areas which are in depression with this kind of filters which I mentioned, with the tube well recharging type of thing. Don't allow the water to flow directly, but let the water get stored into that. And if you have enough depth of soil, then you can use recharge piles instead. Recharge piles can also be done filled with the filter material. It is not required to have proper formal filtering device, except the fact that it can store water and your land subsidence should not occur. Because black cotton soil में open pit अपन खोदेंगे या open channel, open ये खोदेंगे trenches वगैरह, then there is a possibility that that may get displaced and that may get filled up very soon. So to avoid that, you can fill it up with the boulders and something, so that you can have water staying on your campus. And wherever possible, you can grow some trees. Lot of trees, if you grow, then obviously there will be seepage, better seepage. It is experienced that uh, trees planted on the steeper slope will create enormous changes in the overall water situation in the uh, place. So that is one of the major things.
Thank
And
you
if
so much, sir.
sometimes I visit for some exam, etc., because I keep visiting IPS, so we will go together and we all will go together. People who are, because you have a lot of people who are working in water resources engineering and you working in water quality. So I feel that we are all having a very good group. So we'll go and see and understand, try to understand that how can we improve the situation. I will
Definitely,
like
sir.
be there. Yeah.
So we look forward to it.
Yeah. Yeah.
Anybody from the participants would like to interact? So as of now, I cannot see any of the questions from the participants because your uh, topic was so clear and evident that I don't think anybody has a doubt. But still, if anybody comes up with a doubt, we will share it with you on the
as a
email.
teacher, yeah, as a teacher of 35 years experience, I know that there is one possibility that yes, it is understood well. The lecture was very clear. Otherwise, the other side, the flop side of that flip side is okay. But the flop side is that the lecture was so boring.
No,
No,
sir.
sir. No, sir.
Anyway, it's all a joke. So
Sir,
let us.
we as faculties, we try to deliver our best. But what happens
Yeah,
is
yeah.
the student can absorb only according to his or her ability. That we cannot change.
Yes, yes, sure, sure.
So, but we are always ready.
Thank you very much.
Thank you,
Thank you,
sir.
sir.
Thank you so much, sir.
Thank you,
for
sir.
getting. Yeah.
Thank you so much, sir,
Thank
for
you.
taking
Thank
out
you,
time,
sir.
sir. Thank you,
चलो
sir.
बहुत
you,
अच्छा
sir.
लगा आप लोगों के साथ तो हमेशा अच्छा ही लगता है
सर हम तो
Same
आप ही
here.
के स्टूडेंट हैं सर.
अरे नहीं फिर भी अभी भी मिलना जुलना बहुत अच्छा लगता है ये तो कोरोना ने मार दिया है अपने को सबको नहीं तो
Yes, sir.
चलो
True, sir.
ओके बेटा
Thank you,
Thank you,
sir.
sir.
We would like to have
Thank you,
you in
sir.
person, sir. Thank you. So the participants are informed that tomorrow we will be meeting again at 10:30 a.m. for the next session, and we are taking your leaves for today. Thank you.
Feedbacking.
We will be sharing the feedback link. Participants, please find the feedback link in the chat box. That will be active for around 1 hour. After 1 hour, it will be closed.